of Engineers, Hyderabad Local Center, for inviting me for delivery lecture here. Unlike my previous speakers, they are belongs to the some companies, but I am from academics. So my presentation is going to become a research finding. Actually, when we have to understand why of course, say like a human being, the structures bound to comes under the repair. When the structure is under repair, see, as we all understand that, see, as we go, when we fall sick, we go to the doctor, suitable doctor. A doctor assesses and gives the medicine. In the same way, the assessment is most important. Sometimes we find that the doctor is not able to find our illness properly and not giving the proper prescription. That's why illness is being continued. In the same way, here when the structure is under repair, it has to be assessed properly. Unless we assess it properly, then you cannot choose a proper technique. After choosing a proper technique, we have to apply proper material. So the assessment is very, very important when the structure is under damage. And after assessing the structure properly, then we have to choose a proper technique along with the proper material. If the material is not proper, even if the material is proper, if the application technique is not proper, then there is no use of the repair and retrofitting of the structures. So likewise, before starting, one more opening is that the old structures, even if you can say that walls, mud walls, which were constructed 100 years back, hundreds of years back, I cannot say only 100 years back, are standing properly, but the walls are structures which are built now with latest technology are not standing properly for few years. They are coming under the repair. Why? See, in the olden days, like the Charminar, Taj Mahal are standing excellently, but the structures which are built recently are coming under repair within a short period of time. Normally, the concrete structures are built for 100 years. They are not standing. They are not giving the life effectively. So we have to think a lot. And that is the second thing. Third thing is that due to the cost of the material, so the research is going on to use the latest materials, latest technology. And I do not know whether this latest material that we are using, latest technology that we are using, good or bad for the present constructions, infrastructure building. But in the olden days, the structures which were built with even mud, even with lime, are standing excellently. See, because at that time, they used to handle the material with the utmost care. They used to prepare the material properly. That's why those structures are still standing excellently. So that is the thing. Now, as I said, it is necessary to, so my overview goes few points: introduction, evaluation, duration, durability, and durability studies on geopolymer mortar with steel fibers, and conclusions. Of course, I'll quickly go through it. See, the structures deteriorate with the time. Damage occurs due to aging, environment, and overloading and disaster. Of course, the repairs improves the damage. Retrofitting enhances the overall the strength. That is a difference. Of course, this is a small figure which shows the structure is under the damage and the retrofitting of the structures by steel jacketing, FRP wrapping, etc. And there is a little difference between, one must understand the repair and the retrofitting. Repair is a localized failure, is being the techniques used for crack filling and epoxy injection and patching and grouting, etc. Retrofitting, column and beam jacketing, FRP wrapping, steel plate bonding, and addition of steel walls. Of course, the difference is the repair restores the original strength, but whereas the retrofitting improves the strength beyond the original strength. Repair a little less expensive and retrofitting comparatively costly. And the advantages and the chemical a lot of construction chemicals are coming into the construction field, and materials are also used. And here a geopolymer concrete, and this is the ordinary concrete, and this is a geopolymer concrete used by using the fly ash, GGBS, rhesus ash, etc. in addition to the alkaline solutions. And the comparison between the traditional materials and advanced materials. Of course, the advanced material, so far we think that they are more strength, the weight is a little low, and the cost is a little higher, initial cost, and sustainability is high. And evaluation of durabilities, these are the factors influencing materials, environment, load conditions, and construction techniques, etc. And the methods of evaluation of durability: accelerated aging test, non-destructive testing, microstructural analysis, laboratory tests, etc. The durability tests that are required for the concrete are compressive strength, tensile strength, so on and so forth. The chloride ion penetration test, sulfate attack resistance, etc. Steel requires the corrosion resistant test, and polymers require polymers and soils. See, these are all the durability tests that we conduct in the construction materials. And see, my presentation mainly focus is on geopolymer mortar. The tests on geopolymer mortar with steel fibers. These are the 4 tests that we have conducted. One of my research student is conducted and found the geopolymer mortar, that is ternary blended geopolymer mortar, obtained by adding the mica powder, fly ash, and the GGBS along with the steel fibers. How the steel fibers are affecting in this, the ternary blended geopolymer mortar. So as I told, the selection of the material is very important part of the repair and retrofitting of the structures. So first is evaluation method, and the technique that is to be applied, and material that is to be applied. How this material is useful, and how this material is being tested, and what kind of results it is producing. So the main theme is the impact of steel fibers on durability, optimum fiber content, how much fiber content is to be used, and time dependent performance. And first test is the sorptivity test. So sorptivity measures the capillary force exerted by the mortar pore structures, which dictates the penetration rate of mortar. And methodology, cumulative, how do we find out? It is a cumulative absorption is plotted against the square root of the time with the square root of time with the absorption. The sorptivity value is derived from the slope of this linear relationship. So we draw a graph with the cumulative absorption in millimeters and square root of time, and we draw a straight line, and the slope of this straight line gives you the sorptivity value. So this is how we conduct. So I is the absorption value, and MT is the change in specimen mass, that is the weight of the specimen, and A is the cross-sectional area with which the surface area is coming in contact with water, and this is a specimen and immersed in water for 2 millimeter. At the bottom surface is immersed, and the size of the specimen normally 100 millimeter by 50 millimeter by 50 millimeter, and we immerse this specimen under the water for 2 millimeters, and we measure the time, that is a weight, and we take the difference of that weight. And so this is the time in minutes. So the weight is being measured after every 3 minutes, 3, 6, 9, so on and so forth, up to 60 minutes. And the square root of time it is, and with 0 fibers, this is the absorption, and this is the 5% fiber, this is the absorption. So that means with 5% fibers, the absorption is being a little reduced. And finally, a graph is being drawn, and from the graph, the slope is being found. That slope represents the sorptivity, and it is found that with 0% fiber, the sorptivity is 0.928, and with 5% fibers, it is found 0.843. So that means a reduction of absorption is found 14%. And rapid chloride test, so it is the concurrent samples It is a resistance of the motor to chloride ion penetration measured by the total charge passed through the sample in coulombs. So normally if the charge passed is more than 4000, we consider it as a chloride ion permeability is high, and if it is 200 to 400 moderate, and 2000 to 4000, 1000 to 2000 low. Likewise, if it is less than 100, it is negligible. And with the addition of the fibers, so how the chloride ion permeability is found. And here the time interval taken is I0, I30. So that means the 30 minutes, 60 minutes, so on and so forth, it is gone up to 360 minutes. Then cell 1, the chloride ion, the penetration is found in microamperes, and cell 2, cell 3 average. As the time increases, so the chloride ion permeability is being slowly increased. In the case of 0%, it is 20-day RCPT value and 90-day RCPT value. So it is values. So the charge is being calculated by this equation, and the charge passed in coulombs, and I10 current in amperes calculated. And finally, see, with the 5% steel fiber, it is a 20% RCPT value and 90% of RCPT value. So it is 10% steel fibers. Then it is found that finally, as the percentage of fibers is increased, RCPT value is being slowly a little increase. It is found. As age increased from 28 days to 90 days, the charge passed through specimen decreases, and indicating the improved resistance over the time with 5% the fiber addition. So then chemical resistant surface behavior. So the 5% magnesium sulfate is being used, 365 days immersion is being done, and with the fibers variation 0, 2.55, 7.5, 10. So the initial compressive strength of 28 days is being found. So when the 0% fibers, it is 51.64 Newton per millimeter square, and as the fibers percentage is increased, so it is found that for 5% it is 57.68 Newton per millimeter square after immersion of the MgSO4 solution. So the variation of compressive strength 30 days, 90 days, 180, 270, and the 360, to see it is found. So likewise, so the decrease in compressive strength on addition of the 5% is being very less. It is found. So the shrinkage stress average, the average of internal water from the pore system, and the shrinkage values in micro strains as time increases, 3 days, 7 days, 14 days, likewise up to 273 days, 0% fibers, 5% fibers, and so on and so forth, it is found. The value, shrinkage value is found that as the addition of the 5% steel fibers, the shrinkage value is being reduced by 2%. So in every sample, it is found like that. So this is the shrinkage value without fibers. This red line indicates the shrinkage value with the 5% fibers. So the shrinkage value is reduced with the 5% fibers. Then as a summary, the fibers generally enhances the durability of geopolymer motor, improves water absorption resistance, varied chloride permeability, enhances the surface resistance, and reduce the shrinkage. As a conclusion, 5% steel fibers content appears offer the more balanced and beneficial improvement across the multiple durability parameter for geopolymer motors. So these are some of the references. Thank you.